the solutions for the mock exam for exponential and logarithmic functions. Number 1. The diagram shows a chain hanging between two hooks A and B. The points A and B are equal heights above the ground. P is the lowest point on the chain, so P is this point right here. The ground is represented by the x-axis right down here. The x-coordinate of A is -2, so that would be the x-coordinate of A is -2. The x-coordinate of B is 2. And point P is on the y-axis. There's the y-axis. The shape of the chain is given by the function y equals 2 to the x plus 2 to the negative x, where x is between -2 and 2, including the values of -2 and 2. So that's, this function right here. Okay? A. Calculate the height of the point P. And I give you a hint to put the function in your calculator, which is what I always tell you whenever you get a problem on the IB exam where they give you a function. The first thing you're always going to do is put it in the calculator. So let's do that. So we'll put 2 to the x plus 2 to the negative x. And here, since the negative is starting the beginning of a little number sentence there, you're going to use the bottom negative sign and not the side negative sign, which is minus, right? And we put that in the calculator. Now we're going to calculate the height of point P. Basically, we want to know the coordinates of point P. And if you ever wanted to know the definite coordinates of something, probably the best way is to do it using the table. So let's go to the table. What do we know about point P? Well, we know it's on the y-axis, which is an indirect way of telling us the x-coordinate. The x-coordinate is 0. So if the x-coordinate is 0, that means that the y-coordinate that corresponds to x equal to 0 is obviously 2, as we can see in the table. So the answer is going to be 2. Because the height is the y-coordinate, right? This is the side view of a hanging chain, so the y-coordinate is the height as the ground is at 0, right? Another way you could do it to find this is basically the y-intercept, right? Remember that there's another way to find the y-intercept, which is to look at the graph of the function. And this graph is going to kind of look like the graph we're seeing here. The only difference is the graph on the calculator goes farther to the left and farther to the right, because this one is cut off at -2 and 2, and the calculator one is not. So we could find the y-intercept here by doing, of course, trace 0. Trace 0. And even though you already pressed trace, it's already at 0. I always tell you to do trace 0, because then if you want to do trace another coordinate like trace 2 or something, then you know how to do that, right? So here it tells that the y value is 2 at x equals 0, which is what we just found out from the table also. Part B, find the range of y. Write your answer as an interval or using inequality symbols. Okay, so basically remember that range means the valid y values, okay? And in this particular case, we know that like the y values correspond to the height of the chain, and it looks like the lowest height of the chain corresponds to the y coordinate of P, and then the highest coordinate of the chain would correspond to the points A and B, right? So basically what we're doing is we're going to find the y-coordinate of P and the y-coordinate of A or B. It looks like A and B are at the same height, but we're not sure yet. And then those would be the critical values, the numbers, which will define the interval, which is the range. I think the y value at P would be the smallest number in the range, and the y value at A and B would be the largest number in the range. So if we find those, we will know the entire range. It would be all the numbers in between, right? So let's find the y value at P. Oh, wait a second, we already know the y value of P. The y value of P is 2, right? Now let's find the y coordinate of A or B. Now we know that the A point is at x equals -2, and the B point is at x equals 2. So we'll be able to find both of those points very easily using second table. We can see pretty quickly that at x equals 2, the y value is 4.25. So this would be for point B. So I could see this is 2 comma 4.25. And I can also find the y coordinate of A by looking at x equals -2. It would also be at 4.25, and it looked like they were at the same height, and they are indeed at the same height. Remember I told you that with trace, you can actually find other points besides the y-intercept. For example, I could do trace 2, and then that could show me also that I'm at 4.25. So I could do that also. So I know that the range, which is all the valid y values, it ranges between 2, which is the p height, and 4.25, which is the b height or the a height. And so I can put that the y value is in between these two. Okay, the most convenient way to do it is put the smallest number here, the largest number here, and then you put y in the middle. The only question I now have is, should I put less than or equal to, or should I just put less than? The question is, are the points exactly at y equal 2 and y equals 4.25? Are those also on the function? And they are. So we would put less than or equal to. Now, whenever you have an asymptote, be careful, because on asymptotes, is the asymptote value part of the function? No, because remember the function never touches it. Then you would use less than and not less than or equal to, right? Okay, so that was number 1. Let's go to number 2. Number 2, the population of fleas on a dog after t days is modeled by this function. And here they have an n value and they have a t value. They tell us that the n value, well, they don't actually say that the n value is the number of fleas, but they do say that the population of fleas is modeled by the function n. So the number of fleas is n, and t is the time or the number of days. Okay, some of the values of n are shown in the table below. You can see in the bottom row, they show 8, 16, 32, and 128 as values of n at certain values of t. Look at the values of t. They don't give us every single value of t. They give us 0, 4, 8. They're skipping numbers here for some reason. And then it says to write down the value of p and q, which are 2 of these missing numbers for n. Okay. So let's do what we always do at the beginning of a problem where they give us a function. We're going to type the function into the calculator. So instead of t, of course, we're going to put x, and t, it's t over 4. So let's put parentheses x divided by 4. I'm not sure if we need the parentheses or not, but I'm going to put the parentheses there just in case. Okay, so there's my function. And, you know, if I do a second table, aren't I going to get a table that is very similar to this table, except my table is going to be completely filled in, right? And theirs is not. And I can use my completely filled in table to fill in their numbers. And now I can kind of see, why did they skip from 0 to 4 to 8? If you can see, in the table, 0, 4, and 8, they have like nice round y values, and in between they're kind of decimals. So now I can see why they skipped. Okay, so first of all, what is the p value, which is the y value that corresponds to x equals 0? Remember, this one's x and this one's y, and we know that because usually time is the x value, and usually the function y is the variable that's on the left here. The x is usually the input, the y is usually the output. Usually when they give you a table, the top or the left values are x and the right or the bottom values are y, and this is no exception. Okay, so when x is 0, what's y? If we look at the calculator, we can see that the y value is 4. So the p value is 4. What about when x equals 16? What does the y value equal then? So let's scroll down on the calculator until we get to x equals 16. And we get 64. So the value for P is 4 and the value for Q is 64. Okay? And you could also do that by looking at the graph and doing trace 0 and trace 16, just like we did on the last page. Okay. Now, using the values in the table above, draw the graph of n for 0 is less than or equal to t is less than or equal to 20. And then they give us some advice here about how to scale the grid paper. Okay, and then it says to use your graph to estimate the number of days for the population of fleas to reach 55. So let's do the graph. They gave us grid paper on the next page. So they said to use 1 square to represent 2 days on the horizontal axis and 1 square to represent 10 fleas on the vertical axis. So we're going to divide everything up here. So they said on the x-axis, we are going to use 2 days per square. So I'll count by 2's here. Okay, am I counting correctly? Yes, 22. I don't know if I need to go any further than that. What's the biggest number they gave us? 20. So 22 is fine. And now I'm going to count by tens on the y-axis. So, okay, always start with 0. Don't skip numbers here. So I'm going to start with zeros here. And I'm going to count by 10. So it'll be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. I think that's about as big as it gets. Yeah, it goes up to 128. Okay, and then it wants us to draw the graph of n from 0 to 20. And remember, even though the graph kind of shows you what the graph is shaped like, don't use the graph to figure out what values you should graph. You should always use a table to do that. So let's look at the table again. And remember that the table has every single value from all the x values. But they gave us a little hint here. They said if you use the values 0, 4, 8, 12, 16 for x, then you have some nicer values that are not decimals. So just to show that here, I'm going to do +4 so that I change the increment to count by 4s, and then it'll give us some strategic points here that we can use to graph. Okay, so the first point is 0, 4. Graph in blue here. 0, 4 is about there, and 4, 8, 4, 8, and 8, 16, 8, 16, and 12, 32, and 16, 64, and 20, 128. Okay, and that's the last point we want to graph. And then what you want to do is you want to connect it with a smooth curve. Okay, and a lot of times it might say sketch the graph. And in this case, the reason why they would say sketch the graph, even though we're doing a pretty good job of graphing it, is because usually the word sketch if the function is a curve. Okay. Now in this case it says draw, and I don't remember if they actually said draw or if I modified this problem somehow and that's why it says draw. But usually they'll say sketch if they're talking about a curve. That's kind of a hint for you. Okay, so we finished the graph, and then in C it says use your graph to estimate the number of days for the population of fleas to reach 55. Okay, now how do we use a graph to figure out when the population of fleas reaches 55? Well, first of all, what are we supposed to estimate? Are we supposed to estimate x or y? Well, we're supposed to estimate number of days. Number of days is x. And they're giving us the population of fleas, which remember is y. So basically what they're doing is say, I'm giving you the y of 55, find me the x value that corresponds to it, and do it with your graph. So if I was to do that, then I would draw a line from 55, which is about there, until I hit my graph. And then I would look to see where that point points to on the x-axis. It looks like it's about maybe 15.5 or somewhere around there. So maybe I would say 15.5, something like that. So let's say 15.5. Okay. And it says number of days, so you could take your 15.5 and you say, okay, if you want whole number days, it would be 15 or 16. In this case, wouldn't you need to actually get to 16 to actually reach 55? Because 15 would be slightly less than 55. So if you were going to give a whole number of days, you would say 16. If you were going to give a decimal number of days, 15.5. This is a really good example of an IB problem where it's, it would be valid to give a decimal or maybe a whole number. So maybe the safest thing to do is to find a decimal and then say, okay, I'm going to round it to 16 days because that's a whole number of days. And then you would have both answers there. Okay. Now, you could also find this with the calculator if you didn't understand how to do it with your graph. How would you do it with the calculator? You would put the desired y as y2. This is one. I'm going to show you the other way to do it. And then you would graph it. And of course, the intersection point of the two graphs, the horizontal line and this blue exponential graph, don't cross in the window. And so how do we make a cross in the window? We're going to have to adjust the x values and the y values so that it fits. And to do that, let's first take a look at the x values. The x values should be between 0 and 20, right? And the way we adjust x values is using window. So let's adjust the x max to be 20, because that's the maximum x value we're seeing here. And then the other thing that we need to adjust is the y values. The way we adjust the y values is we do zoom fit. Zoom fit is what we use to adjust the y's. I think it's still graphing. Okay, oops. Okay, zoom. And then zoom fit, remember, is I think option 0 or something. Yeah, there it is, option 0. So you can just type 0, enter. And then it will do the best job possible of graphing the blue function and the red function so that they both fit. And then we'll see around where the 55 flea red horizontal line is. And now we can find the exact value of x by doing second calc intersect. Remember, they told us to use the graph. So we would want to use the graph. But if you were unable to use the graph, or if you wanted to confirm your answer, this is how you would do it. So the answer is 15.13, about 15.1. So actually, if you use the calculator, you can see that the answer is actually 15.1 instead of 15.5. It's kind of hard to see on the graph to see exactly where it was between 15 and 16, but that's okay. What you need to do is you need to do it on the grid paper and then leave evidence like this vertical and horizontal line to show why you got the answer that you did. Okay? And then one last way that you could do you could find that answer is you could look on a table and go back to delta table of 1 and then go down and see. Now, in this case, we don't need the y2 value set here, so let's get rid of that. And then, oops, not the graph. We're going to the table. Okay, now it's going to graph the whole darn thing. So slow. This calculator is so slow. Okay. So then we go to the table, and then we're going to try to find when the y value, when the blue numbers get to 55, right? Because that would be what we're looking for. We're looking for how many days does it take to get to 55 fleas. And the answer is, looks like 16, right? We have to go all the way to 16 to get to past 55, which is 64. And if we wanted to get a more precise number, we could do plus 0.1 and count by 0.1s. And then we could see that actually 15.2 would be the value that it would take to actually surpass 55, right? And if we wanted to get an even more precise number, then we could do plus 0.01 and get an even more precise number, okay? So those are ways of getting really precise numbers. I'm just showing you that as a review. One last thing. Be very careful to label. So here we should put days or T or something like that, T in days. And here we should put N in fleas. On a graph on the exam, you should always label your axes, even if sometimes I forget to do it when I'm showing you a solution. You should never forget on an exam or on the IB exam. Number 3, consider the functions f of x equals 1.25 minus e to the negative x and g of x equals natural log of x. The diagram shows a sketch of the graph of f for the values x is greater than or equal to 0, which means just the positive x values are shown. Maybe it goes, more that way, but they're not going to show us that is what they're saying. The graph intersects the y-axis at point A, and the line L is its horizontal asymptote. Find the y value of point A, and my hint is, what is the x-coordinate of point A? Okay, so they actually draw A for you here, and they also show you where the x and the y coordinates are. They don't put numbers on the scale, so it makes it a little bit hard to see exactly what A is close to. But they did give us the function. This function, by the way, is function f, right? It says the graph is of function f. They also gave us function g, which is not shown on the graph, okay? And so what we're going to do first is, first we're going to fix our calculator so that the table's not all messed up. So go to second table set and change your table start to 0 and your delta table to 1, so your table's back to normal. And they gave us the function f 1.25 minus e to the negative x. So we are going to type that in to the calculator because that's what we always do if they give us a function. Remember, we type using second ln, and then we put negative x, and make sure you use this little negative sign at the bottom. When you are putting it for an at the beginning of an exponent, you should put this here at the bottom. And then let's see, we're going to figure out what the point A is. Let's graph it for a second. Oh, we need to fix our graph too so that it's like it was before. Okay, so I am going to go to Zoom Standard. So I go to Zoom Standard, which is option 6. And then now it's going to look more like this drawing here. Except this picture graphs even the negative x values, and this one doesn't. Now, what would you call this point here in math terms? Wouldn't you call that the y-intercept? We want to find the y-coordinate of the y-intercept, okay? And that's the hint. The hint is what is the x-coordinate of point A. The x-coordinate of point A, if it's the y-intercept, is x equals 0, right? And if we want to find what the value of this function is at x equals 0, there's a couple ways to do that. One of the ways is second table. We can see that the y value that corresponds to x equals 0 is 0.25. So we immediately have the answer there. And we could also see that by graphing and doing trace 0. Right? And that would also give us the y value of 0.25. Okay? And then it says to write down the equation of L. L looks like it's the horizontal asymptote, and they indeed confirm this in the explanation. Okay? So the equation of the horizontal asymptote, there's a couple ways to do that. One is, okay, looks like the horizontal asymptote's on the right side of this thing, so the positive values of x. So if we go to second table and we start going down the table, down to see what the y values do as we go down, we can see that eventually it gets to the point, 1.25, where it just stops getting bigger. So that must be the value of the asymptote. So the value of the asymptote is 1.25. How do we express it as an equation? Remember, the asymptote, the horizontal asymptote would always be given as y equals 1.25 because that's how you write the equation of a horizontal line. The equation of a vertical asymptote would be x equals something because that's how you write a vertical line. So in a horizontal line, you always write y equals something. So if you ever get a problem where they ask you to write the equation of a horizontal asymptote or a vertical asymptote, you must write x equals y equals first. Okay, just like when we had axis of symmetry, if you were going to write the equation of the axis of symmetry, you always need to write x equals a number. You can't just write the number because otherwise it won't be the equation of a line. Okay? All right. And another way you could do it is, in this particular case, do you see how the equation is nicely separated into a plain number and an exponential part, and there's no parentheses or anything? If you're in that special case, then you could see that the value of the asymptote is actually written plainly there as a separate number, 1.25. Okay? All right, so we finished that part. Final part, C. For what value of x does g of x intersect the asymptote L? So g of x, remember, is this other function they gave us, which they did not graph, which is natural log of x. They want us to find the intersection between natural log of x and the asymptote y equals 1.25. So why don't we do this? We're going to get rid of this function here. We're going to replace it with the equation of L, 1.25, and then we're going to put in natural log of x as our second function. Okay, and then we're going to graph that, and they want to know where do they intersect. So that's pretty easy, right? We know how to find intersections. We find intersections by doing second calc intersect. So let's do that. Second calc intersect, option 5. And then since there's only one intersection here and it's plainly seen in the grid, we can just hit enter 3 times. Now, one pegadilla on this is when we hit the enter, when it's talking about the natural log function, it doesn't do anything, okay? The reason why is because the calculator freaks out because natural log and log, those functions don't exist at the very center of the graph x equals 0. So while you're pressing enter, it's like, where is the log function? I don't know. So the way you tell it where the log function is, oh, calculator, go a little bit to the right, and you hit the right arrow a little bit, and then it finds the log function. And then when you hit enter, it'll say, oh, okay, yeah, the log function, I see it. And then when it's time to guess, you just hit enter again, right? Normally we just hit enter 3 times when we do second calc intersect. In this case that you have log, it's this little pegadilla that the thing is like, it doesn't register when the cursor is directly at x equals 0, which is usually where it starts. Okay, so the intersection is 3.4 something and 1.25. So I'm going to write that down here. 3.49 comma 1.25, I think. Let me zoom in with my bifocals to see exactly what it is, and I can't. I have no idea what it says. It looks like it says 3.49. I'm not exactly sure. Let me pause for a second and make sure. Okay, just confirm that the calculator really does say 3.49. So the x value where it does intersect is actually 3.49. Okay? Alrighty, and that's it. That's the end of the mock exam.